I realized as I was making the video for this section that there are a couple of assumptions that I want to be able to make with you as we go along. And so I'm going to take a minute before I start, before you watch that next video. I'm going to take a couple of minutes and just talk about those assumptions. One is that if y, if some function y, is a solution to a differential equation of this particular form. This is a second order differential equation, and there's a second order, there's a second derivative term, there's a first derivative term, and there's a term that has not had its derivative taken. The derivative of y has not been taken. And the coefficients of those terms are constants. And the point we want to make here is that if y is a solution to a differential equation of this form, then ky is also a solution for any real number k. And so let's demonstrate that here. Let's take ky and plug it in to the equation that we have here, or the left-hand side of it anyway. We have a y double prime plus b y prime plus c y, and I'm replacing each one of those y's with ky. And what I want to find out, what I want to try and establish is that also equal to 0? Because if y is a solution, then y's derivative and y's second derivative, when plugged in here, will return 0. So if ky is also a solution, then plugging those in will also return 0. So I'm not setting this equal to 0. I'm trying to demonstrate that it is equal to 0. Well, I think what I'll do is I'll start with the last term over here. This is just algebra. This is just c, k, y, right? Just distribute the c, or just remove the parentheses, really. The second term is b times the derivative of ky, but k is a constant. So the derivative of 3y would just be 3y prime. So this is just going to be k b times k y prime. And then the same thing happens when you take the second derivative. The first derivative is just going to be k y prime. Because it's a constant, the second derivative is going to be ky double prime. All right, so now that I've established that, I notice that the only thing common to all three of these terms is the k, so I'll pull that out, and I'm left with a times y double prime plus b times y prime plus c times y, and that's going to be equal to k times, well, guess what? This equation, this left-hand side of this equation, this thing here equals 0. So I already know the value of this. And so I can say that that's k times 0, which is 0. And that lets me say that if y is a solution to a differential equation of that form, then ky is also a solution. Now that's going to come in handy in a little while. And I want just at the time when it comes up, I want just to be able to say, to state that outright, just to assume it. The other one is that if y1 and y2 are two different solutions to the same kind of differential equation, if these are two solutions to that differential equation, then the sum of those two solutions is also a solution. And we're going to do the same thing here. We're going to take a y double prime plus b y prime plus c y, and we're going to replace the y with y1 plus y2. y1 plus y2 in each case. And then we'll work out what that looks like and see whether we can compare it to the original differential equation. Well, here I have, I think I'll start with my last term again. I think that's just a little bit easier. I have just pure distribution here, cy1 plus cy2, that's just algebra. My second term is b times the derivative of a sum. Well, if I have two functions, f of x and g of x, and I take the derivative of that sum, that's just the sum of the derivatives. So that's going to be b times y1 prime plus y2 prime. And the same is true with the second derivative, because I'm just doing that sum, the derivative of the sum thing twice. So I have y1 double prime plus y2 double prime, and then I can just distribute. Okay, now let's pull together all the stuff that has y1 in it. So I have a y double prime, y1 double prime, plus b, y1 prime, plus c, y1. And then we'll add to that the terms collected that have y2s in them. So we have a y2 double prime plus b y2 prime plus cy2. And if you look at this, you'll see, if I collect things that way, that this is the left-hand side of my equation here for this particular solution. Remember, if y1 is a solution to this thing and y2 is a solution to this thing, then I can replace y with y1 here and I'll get 0. Or I can replace y with y2 and get 0. So this thing right here is 0. And so is the other one. So this gives me 0 plus, I said 0 and wrote plus, 0 plus 0, which is 0. So that also works out for us. And that lets me say this. If I have two solutions to a differential equation of this form, then the sum of those two solutions is also a solution. And to be as general as possible, the way that I'm going to write this is to say, in fact, let me do this. I'm going to give myself just a little extra room down here. And then I've written the most general form of this statement down here. If y1 and y2 are two solutions to a differential equation in this particular form, then k1y1 plus k2y2 is also a solution. It's general because I can assume k1, because it's a real number, k1 could be 0. So what I've said here is that if these are two solutions, then just a multiple of one of those is also a solution. Just a multiple of the other is also a solution, or a combination of the two. The sum of those two, k1 and k2, can also be 1. Right? So this is the most general form of this statement. So this is the assumption, or these are the assumptions that I wanted to be able to make with you in the next video. And I started making that video without having established this. So now I have. And so now, having established those preliminaries, we can go on to our next adventure.